Thanks for tuning in, guys. In this video, we will discuss our question 4 for this November 2019 question paper. It's a question on our ideal gas laws. So in the description below, uzothola ama links for amanye question paper ungakhohlwa. As usual, guys. Now, Lana, I have an interesting problem, I believe. Sikhuluma ngama gas laws, specifically uloga Charles law. Right, 4.1, but the Charles law describes the relationship between the volume and temperature of an enclosed mass of gas at constant pressure. So, with Charles law, we know that pressure is kept constant, and then the only two variables are changed are volume as well as the temperature. Now, as you can see in the table, basically volume as well as the temperature, while pressure is kept constant. The volumes of a gas at different temperatures at constant pressure are given in the table below. So bheka-ke manje, as the temperature increases as well as the volume does what? It also increases. So ngathini? Angisho, we know that the temperature measure the average kinetic energy of the particles according to the kinetic molecular theory, right? Siyazi ukuthi a substance in the gaseous phase, right? The particles are free to move. So now increasing temperature, they create more space between the particles, thus creating or increasing the volume occupied by Lauma particles. So 4.1.1, but explain Charles' law in terms of the kinetic molecular theory of gases. Kinetic molecular theory, we discuss about gases. It's a theory for the different states of matter, your solid, liquid, and gas. So lana sizo but say the kinetic molecular theory to explain ama gases in the view of iloganj Charles law. But before nginikeza explanation la, in fact senginikezile, but before ngizoyibhala phansi, let us state uloganj Charles law qala. So Charles law uthi the volume of a fixed amount of gas is directly proportional to the Kelvin temperature of the gas at constant pressure. Kelvin temperature, keep that in mind, especially now when our calculations wako. Our temperatures wako must be converted to the Kelvin temperature scale. So now, since if volume is directly proportional to the temperature, as we can see kulama findings now, increase in temperature, the volume also increases. Why kenzeka lo? Say for instance in a container la, container yami contain ama particles, and then at a given temperature ama particles wama aya move at a certain amount, at a certain value of average kinetic energy, right? But the moment in increase temperature, bekalama arrow lawa seka longer than the ones on the particles on the left of this box. So it means an increase in temperature increase in the speed of the particle. So therefore, I create a more, there will be more space between our particles. There will be more space between our particles. More space between llama particles because of a mover further and further apart because of an increase in temperature. So it means that the kinetic energy in this enclosing is over greater than the kinetic energy in this enclosing. So therefore, in conclusion, singathi ke when the temperature of a gas increase, or let's say when the temperature of a gas decreases, the average speed or the average kinetic energy of the particles also does what? It also decreases. It also decreases. So therefore, the number of collisions also decreases. And also what? The volume decreases. But lana ngi-explain using or ngi-explain by an increase in temperature. The opposite is also true. If in increase temperature of the gases, the average kinetic energy does what? It increases. So when I increase, the number of collisions does what? It increases, and the volume does what? It also increases. Singayibeka kanjalo ke, yabona? When iloku kanje i-volume when the temperature increases, ungayi-explainer when the temperature increases or when the temperature decreases, vice versa. It's the same idea because lawo definitions are the same idea. Now, all right, to answer uloganje u4.1.1 abathi sistate uCharles law, but we need to explain using the kinetic molecular theory. So sizoti when the temperature increases, when the temperature increases, atingibhale fast. All right, now again, when the temperature increases, the kinetic energy of particles increases, right? I move fast, and the space between particles increases as well as the number of collisions. Therefore, the volume does what? Increases. This is your 2 marks again, right? Ungayibeka ngamagama wakho, it's fine, but it should catch lelo kanje le idea le. Temperature, it's a keyword. Average kinetic energy, it's a keyword. Volume increases, it's another keyword. Now, 4.1.2, draw a graph of volume versus temperature at constant pressure on the attached graph paper. So, this is the graph paper abakuprovide yona, right? This is the graph paper abakuprovide yona. So lana bafuna ukuthi uplote a graph using the data on the given table. So the horizontal scale already sebasifakele ini ama values, so ihamba nga 50 by a step of 50. So lana 0, 50, 100, 150 la, right? We need to provide the vertical scale. Also label whenever but you plot a graph, make sure that you label your vertical scale as well as the horizontal scale, and then you provide a title for your sketch. So lana again, since lana the volume imove by, well, I think the smallest value one 114 and the highest value one 155. So looking at the graph paper basiphe yona le, I think kuzoba a good idea ukuthi si mark, and then uyabona ngimark kanjani, since lana it's from 0 to 50. So this tiny block nyana le, uyabona, this tiny block nami nangizomarka la kule vertical scale, I also have to use the same marking la, right? So lana ngizoyihambisa ngo-110, 120, meaning ngihambisa nge-step of 10, but starting from 110, 20, 30, 140, 150, and 160. Komele iphelele lapha just above, and then lana it's 160. So lana sinani ke la, on the vertical scale we have a volume in centimeters squared, in cubic centimeters, and then temperature, the horizontal scale temperature ke. This is the temperature in degrees Celsius. in degree Celsius. Right, now let's plot. So 0 degrees is 114, so 110, 120, let's see, it's 1 2 3 1 2 3 4, 114, 15, 16, 17, yeah, 114. You can count line 114 to 0, and then 124 to 25 degrees to 25 or 24, yeah, 25. So it's 1 10 20 30 40. Hayi man, yaba njani? Okay, so lana izothi 10 20 angiboni kahle. Okay, bheka lana, it's going to be, I think lana ihamba ngabu 20 la, is it? 1 2 3 4 5 6 7 8 9 10. So it's 10. If ngizothi 10, no, as ihamba njani, ihamba so, ithi 10 20 30 40 50. So ihamba by 2. Ihamba by 2 in terms of abu 10. So mina ngifuna u25 somewhere la, and then 124 somewhere la, so into engizoyenza ngizoyiplota, then ngiyaqhubeka ngiyarecorda ke. Alright ke, nayi graph yethu ke. So this is volume versus temperature, so this is our plot. Bengafuna waste any time plotting lama points la while recording, so I paused our plotter. So this is what we have. It's a straight line graph. So this is directly proportional to that. Now next question here, 4.1.3, but it's extrapolate. We need to extrapolate the graph, in brackets extend the graph, and state at what temperature the graph intersects the x-axis. Let's see. So extrapolate, meaning you extender this line ngapha, you extender le line le. Nangiqeda ukuyi-extender, ngifuna ukuthola ukuthi i-intersector kuphi le graph, and that will be the answer. So lana i-ruler yami lena, and then I'm extrapolating. Naito yenzayo, you just extend this line, and then nawuqeda uku-extender, you check ke manje. Since angimakanga anything, bekufuneka ukuthi sibe ne-ruler, la. Right, now intersector la kufuneka intersecte this point, and this point normally it's minus 273 degrees Celsius usually, and isitshela ngani, nge-absolute zero. Absolute zero. So this is our answer. Now extrapolate. Usually this is what you get as a value. So lana, I don't have a ruler to measure the actual point, so that you combi so with the that's the value. Right, now see up again, my 4.1.4. What is significant about this temperature? Njengoba ngishilo, it's what? It's the absolute zero, which is the coldest possible temperature at which particles are moving here, right? Ama particles wakhe akamuvi lapho. Let me erase this. 4.1.4. What is the significance in the absolute zero temperature? Njengoba ngistate is the absolute zero temperature, and it is the lowest possible temperature. The T temperature, I mean with the temperature, it's the lowest possible temperature where particles don't have or no kinetic energy. They are stationary. Vibrator nje kuphela. Right, now 4.1.5, calculate the volume that this gas will occupy at 120 degree Celsius at constant pressure. Asize la. Ngifuna ukwazi the volume. Okay, bheka. You can choose any point la on the graph. Let's take out the data here. Since lona Charles law, pressure remain constant. This is the universal law of our gases. 1 P2 V2 divided by T2. Since what remains constant is pressure. So pressure out. So kusala ini V1 over T1 equal to V2 over T2. Now Charles law ke. So the data engidingayo V1. Asebenzise the last one, 155. Temperature is equal to 100 angisho plus 273. Why in plus? Because of the temperature is in degrees Celsius. Ngifuna ini? Mina ngifuna temperature yami ukuthi ibe ku Kelvin scale. So 100 plus 273, it's 373 Kelvin. And then what else? T1 lona, and then volume 2. It's what I want to calculate the volume that this gas will occupy at this temperature. At a different temperature, the given temperature number 2 is 120. So I'm at 273. Let's see. 120 plus 273, 393 Kelvin. The volume is in cubic centimeters, so it means the answer here to give my cubic centimeters as well. Now let's plug in our values to the formula. So volume 1 is 155 divided by T1 373 equal to volume 2, volume enifunayo T2 393. V2 is equal to 155 divided by 373 times 393. V2 is equal to, let's calculate, 155 divided by 373 times 393 equal to, in two decimal places, it's 163.31. 163.31 cubic centimeters. Izophuma as ama cubic centimeters, since volume yethu simeasure as ama cubic, siyekele as ama cubic centimeters. Now for the next question, the experiment is now conducted at a lower constant pressure. On the graph drawn for this one, 4.1.2, sketch the graph that will be obtained at a lower pressure. So lana ke, let's go back to this one. I think erase la qala. Let's go back to this graph here today. Let's go back to this graph. So at a lower pressure, is it? At a lower pressure, experiment at a lower constant pressure. So at a lower constant pressure, it means kuzoba nani na more volume, right? Kuzoba na more volume. kuzoba na more volume. So it means that function yethu, or the new graph, izoba something like this. Izoba something like this. Something like this. Ngoba at the lower pressure, the volume does what? Increase kancane. So izoba ngaphezulu nyana. So this is the new sketch. Let's call it low pressure. Low pressure. For the next question, 4.2, an unknown gas with a mass of, okay, CP mass la, occupies a volume of, at a temperature of, and a pressure of. Assume the gas behaves as an ideal gas. So this is a question on the universal gas law, right? Ngoba ngibona ngani, ngibona ukuthi ngoba basipha i-mass la. The mass, since the mass is given, it means, so sebenzisa hang on, 4.2, since the mass is given, so sebenzisa PV equal to nRT. So sebenzisa this formula, the universal gas law. There's also another one, PV over T equal to PV 1122 divided by T2. This is also a universal gas law, but lana mass or moles remain constant. Lana they are not constant since basiphe 1, right? So kuyosebenza this one. Let's take out the data again, manje. Am I given any pressure? Yep. Pressure is equal to 96. The question, but to calculate the molar mass of the gas. So siyophendula yona la 4.2.1. 96 kPa. But now sebenzisa le formula le, your pressure must be given as, or must be measured as pascals, not kilopascal. So the kilopascal commonly converted to pascal. So you multiply by 1,000. And then what else? Basiphe in futhi, basipha i-mass 0.77 grams. Baphinda basipha nani futhi ne-volume 0.32 cubic decimeters. Your volume is right. Now cubic centimeters we converted to decimeters. Decimeter cubed. Temperature is given as 27. So you add another 273. So you convert it to kelvins. So you convert it to kelvins. So thola ubani 300 K kelvins. 300K kelvins now. And then what else am I given? Temperature and captured. Okay. Yiko lo basiphe kona, right? So into calculate la. Pressure nginayo, volume nginayo, the R I have is a constant, and then I have the temperature. So calculate the number of moles. So funa calculate ini molar mass of the gas. But first, before ngakhona calculate molar mass, kumele ngithole the number of moles. Ngisebenzisa mass, not the number of moles, to calculate the molar mass. Alright, now let's substitute P pressure. It's 96 times 10 exponent 3, volume 0.32 equal to number of moles. R is a constant, 8.31 times 300. N is equal to, dividing both sides by lama value lawa, n is equal to 96 times 10 exponent 3 times 0.32. Sing remove lama brackets, but the multiply and lama brackets, I mean are the same thing. 31 times 300. N is equal to, let's calculate, 96 times 10 to exponent 3 times 0.32 8.31 times 300 equal to, this is our answer, 12 bunny. Oh, our answer is 12.322, 12.322, right? Okay, ngenzeni manje la. All right. Now answer it, but something is not right la. Why ingaka the answer? Oh, okay, guys, began la. This volume is in cubic decimeters. Komele ibe kuma cubic meters, not cubic decimeters. Komele ibe kuma cubic meters. So komele ngithi 0.32 times 10 to exponent minus 3, right? Ngoba ngidivide ngo-1000 la in order to change it to ama cubic meters. So lana is my bad, man. Mistake guys. Okay, I think it's so. I think erase la, and then the substitute again. So 196. So 196 times 10, 3. In fact, I think ibhale as n equal to p times volume. Volume ubani? 0.32 times 10 to exponent negative 3 divided bese ngidivide ngo-RT 8.31 times temperature of 300 K. There's no need for my units now. So n is equal to, let's go back. Yeah, inkulu kakhulu. That value is too big. Inkulu leya value le. Times 10 to exponent minus 3 equal to, okay, makes sense again manje, 0.012 3. I think round off to 4 decimal places. Mole thina sifuna ini? I-molar mass. The number of moles is equal to mass over molar mass. So the molar mass is equal to mass over the number of moles equal to the mass is 0.77 divided by 0.0123. If we give out 12, it wouldn't make sense ukuthi ilo kanje i-molar mass yethu ibe incane, since the molar mass isitshela ngani? Isitshela nge-element. 0.77 divided by 0.0123. The molar mass yositshela ukuthi what type of element is this. So this is the molar mass, 62.60 gram per mole. So this is our answer. And then verse 4.2.2, write down the molecular formula or name of the gas named in 4.2.1. This is the molar mass ezositshela ngani? Nge-element. Siyazi ukuthi molar mass ye-hydrogen it's 1. The molar mass for helium it's 2. And then the other ones now anama values wakhona. Now let's find the element in a molar mass of 62.60. I think thole i-periodic table ke manje. Okay, now periodic table again, man. This is the periodic table. Let's check the element in 62. Remember, it must be a gas. Okay. I'm a metals now. Now we have my gases. There's no gas with 62.60. So it means it's a compound. It's not a gas as an element. So it means it's a compound. into ongayenza nayo mhlambe just play around with lama values lawo with abulo kanje abu oxygen, nitrogen, oxygen, sulfur, fluorine, chloride, bromine, but angeke ifike la kubo bromine lesi siyayikhansela le i-out na this one si-out ngoba imolar mass yakhona seyinkulu indlula the one esiyifunayo. Chlorine, let's see. Chlorine is 62.60 minus 35.5 equal to 27.1. Okay, right, lana it's trial and error kahle kahle. If I vary la ku-periodic table kwamele udlale around ngalama values lawo 62.60 minus 32 for sulfur equal to 30. Uyabona lo 30 lo it's 2 times ubani around 2 times ulo kanje 16, is it? It's 1. 16 times 2 is equal to 32. Mina nginobani kana 62. Man, lento lena no. But nayingaveli ku periodic table, just make sure ukuthi you play around lawo ma values lawo, right? You just play around, just try to subtract and see ukuthi it's a combination of which elements, right? By comparing ama molar masses. So this concludes our video. Unfortunately azange sikhona ukuthola 4.2.2. ngibona ngathi uzothatha a bit long for me nokuthi ngi-identify the compound since it's not an angle, since it's not an element esiyithola on the periodic table. So thanks for watching guys, asibonane kule video elandelayo. If you are new to this channel, consider subscribing. Nangabe ubona ngathi there's value in this channel, now we enjoy this video, leave a like, comment in the comment section, let's talk. Asibonane kule video elandelayo guys. In the description below uzothola ama links for amanye ama questions for this question paper. Thanks for watching. Bye bye.